Today we are going to learn about optimizing PyTorch models for efficient GPU training. We will explore key techniques to optimize PyTorch models effectively, including GPU utilization, data handling, mixed precision training, and more.
Welcome to our video on optimizing PyTorch models for efficient GPU training. In this session, we'll explore various techniques crucial for reducing training time and enhancing model performance. By the end, you'll be equipped with skills to utilize GPU resources effectively, manage data efficiently, and apply advanced training strategies in your machine learning projects.
To begin optimizing PyTorch models, understanding GPU utilization metrics is fundamental. Monitoring these metrics helps identify if your GPU is underutilized, allowing you to make necessary adjustments. Tools like nvidia-smi provide real-time utilization stats, showing GPU memory usage and computational efficiency. By analyzing these metrics, you can pinpoint bottlenecks and optimize resource allocation. This understanding is crucial for ensuring that your GPU's potential is fully harnessed, reducing idle time and increasing throughput. Effective utilization leads to faster training processes and better model performance.
Data bottlenecks can significantly impact model training efficiency. They occur when data loading is slower than the GPU's processing capabilities. To resolve these, optimize your data loading pipeline using PyTorch's data loader with asynchronous loading. Profiling your data transfer times helps identify slow processes. By balancing data loading and computation, you ensure the GPU is constantly fed with data, minimizing idle times. Techniques like prefetching, caching, and using efficient data formats can further alleviate bottlenecks, ensuring smooth and efficient data handling. Mixed precision training is a powerful technique to optimize model training on GPUs. By using lower precision, like FP16, for certain operations, you can significantly reduce memory usage and increase computational speed without sacrificing accuracy. PyTorch's automatic mixed precision, AMP, simplifies this process, allowing for effortless integration into existing models. AMP automatically selects which operations to perform in lower precision, balancing speed and accuracy. Employing mixed precision not only speeds up training but also enables larger batch sizes, further enhancing throughput and performance. PyTorch's data loader is a robust tool for managing dataset loading. To utilize it efficiently, consider employing multiple workers, which can parallelize data loading and reduce latency. Optimizing batch sizes is crucial. Larger batches may increase speed but require more memory. Additionally, implementing data augmentation within the data loader can enhance model robustness without incurring extra processing overhead. By fine-tuning these parameters, you ensure that your model is never starved for data, maintaining a steady flow to the GPU and reducing overall data loading times.
Profiling your model's performance is essential to optimize resource usage and improve efficiency. PyTorch Profiler is a comprehensive tool that helps identify performance bottlenecks by analyzing operation times and resource usage. By examining detailed reports, you can pinpoint slow operations and optimize them, ensuring balanced resource allocation. This analysis not only helps in improving model speed but also in reducing unnecessary computational loads, leading to better overall efficiency. Regular profiling is a proactive approach to maintaining optimal model performance throughout the training process. Finding the optimal batch size is a balance between memory usage and computational efficiency. Larger batch sizes can speed up training by utilizing more GPU resources, but they also require more memory. Conversely, smaller batches use less memory but may result in longer training times. Experimenting with different batch sizes allows you to find a sweet spot for your specific GPU capacity and model architecture. This balance ensures that your GPU is used efficiently, enhancing both training speed and performance. Gradient accumulation is a technique to manage memory usage effectively by simulating larger batch sizes. It involves accumulating gradients over several mini batches before performing a backpropagation step. This approach reduces the memory footprint, allowing models to be trained with effective larger batch sizes without needing additional memory. This technique maintains high model accuracy and optimizes resource utilization, making it a valuable strategy when dealing with limited GPU memory. By carefully implementing gradient accumulation, you can efficiently manage memory constraints and enhance training throughput.
Model parallelism involves distributing different parts of a model across multiple GPUs, enhancing computational efficiency. This strategy is particularly useful for handling larger models that don't fit into a single GPU's memory. By dividing the model, you can leverage multiple GPUs to accelerate training, increase throughput, and support more complex architectures. Implementing model parallelism requires careful coordination between GPUs to ensure seamless operation, but the benefits in terms of speed and capacity can be substantial, allowing for more ambitious machine learning projects. In conclusion, optimizing PyTorch models for efficient GPU training involves a combination of strategies, from understanding GPU utilization metrics and resolving data bottlenecks to implementing advanced techniques like mixed precision training and model parallelism. Regular profiling and adjustment ensure that your models remain efficient and effective. As you apply these strategies in your projects, you'll see improvements in training speed and model performance. Continual learning and adaptation to new techniques will keep you at the forefront of machine learning advancements. Thank you for watching, and happy optimizing.